Yay, we finally come to the applications of electrolysis. We've learned all the electrolysis because it is so useful in our daily life. So the first one that we're going to deal with, okay, that will be the electroplating. Electroplating, okay, you can use at many different kind of articles. So the advantage of that, okay, is to make the article, make the object looks better, more attractive, okay. So we can make the object looks attractive. Other than that, okay, you should remember in chapter 13, we also have this electroplating words come up already. That one, okay, you have to remember, okay, we can increase the corrosion resistance of the objects. So these are some of the advantage. Okay, we can like make it looks better. Okay, you can increase the corrosion resistance. So how we can do it? So you can refer to the textbook page 26 to 28, the electroplating. This setup, okay, you can see that, okay, we put a key. That will be the object that we want to be plated. And at the same time, okay, we can put a copper as an anode right there. So from the diagram, you can find that, no. So first of all, you can have a look of the cathode and anode distributions. And also you can find the iron table right there. So from this iron table, you can find that, okay, again, the iron part, okay, the Cu2 plus will discharge. That means at the cathode, the Cu2 plus will get on it. And then this Cu2 plus will then become Cu. So you will anticipate some of the metal, copper metal, will form on the surface of it. So as copper, it is a reddish brown solid. So you'll find that the key after the electroplating, it will be coated with some reddish brown metals on the surface of it. But at the same time, you can find that on the other side, the anode part. So anode, anion this time, okay, will have sulfate, hydroxide, but more important, you also got Cu. So right here, you'll find that Cu will then be discharged because it have a higher position in ECS. It is a stronger reducing agent. So this one, it will keep on giving out Cu2 plus right there. Okay, so this Cu2 plus regenerate, it can replenish the Cu2 plus discharge. So we will anticipate the intensity of the blue solution, copper 2 sulfate, will more or less the same because Cu2 plus discharge will be replenished by the Cu anode, it will give out Cu2 plus. So the concentration of Cu2 plus will be the same. So from here, we can find that, okay, at cathode, which is the key, we will see that the Cu2 plus will receive electrons and become Cu. So that's why the key will be having copper metal coat on the surface. While at the other side, the anode part, you'll find that the Cu will releasing electrons and become Cu2 plus. So this Cu2 plus keep the concentration of copper 2 plus the same. So the observation that we can see, one of them, you can see reddish brown solid deposits on the surface of the key. So obviously this one is very important. Second one that you can see is about the the color intensity. So just now we explained the color intensity of the blue solution will remain unchanged. So the reason for this one, okay, you can refer to the previous explanation. We'll find that for every Cu2 plus ion discharged at cathode, every one of them they generate, one Cu2 plus ion will form at anode. So you can find that the concentration of Cu2 plus does not change at all. So therefore the intensity of the blue color will remain the same. So these are the two observations that we can see. One more you can think of is about the Cu. If this copper keep on reacting to become copper 2 plus, you'll find that this copper anode, it will become thinner and thinner. Okay, it can reduce in size. Okay, so the copper anode becomes thinner. So these are some of the observations that you can see in the electroplating. And what do you need to learn? Okay, what do you need to do for revising these sections? First of all, you need to know how to sketch a electroplating setup. So first of all, you have to see that, okay, we have positive and negative. We got cathode, we got anode right there. So the anode, okay, suppose is going to connecting the anode of the chemical cell, suppose connecting with the cathode. So bear in mind the plating objects, okay, will be on the cathode, okay, because if you got the key, you want the metal ion stick on it, so therefore this one have to be cathode. Okay, so the key, okay, we'll draw like this. Okay, while the other one, okay, we got a plating metal. So when you put the electrolyte here, you'll find that, okay, the metal will then plate at the electrode which dip into the solution. So this is not something that you want to see, because you want the whole key covered by the metal. So this kind of diagram, you score 0 mark for this, just because of the key is not completely immersed into the solution. So to draw better, you have to find that you have to draw the key and the metals, and then the solution have to be fully covered the metal. Then this one will be correct. Okay, so to label that, okay, so this one is a key object to be plate. So this one will be the plating metal. It really depends on what kind of metal you're going to plate on the key. If you are, okay, what other plating material we can have? Okay, for other plating materials, we have like copper, tin, chromium, silver, nickel, gold. If we are doing like that way, okay, coating these kind of metals on the key, then the plating metal have to be changed. This time we're using copper because we plate copper on the surface. But next time if we're talking about tin, then I will put tin right here. If we talk about silver, we put silver right there. Okay, so this one, okay, is a plating metal. So how to make the things plate better? Is it just do like that will be okay? So remember, sometimes we have to control the conditions. So if we control the condition well, then we can result in a smooth and firm deposit on it. That means it won't be shaded off easily. Okay, so the deposit, it can stick firmly on the object by controlling the conditions of the electroplating. So in this case, you'll find that, okay, the objects have to be key, because that is part of the electrode. What if we have non-metal? Can we like plating a non-metal object? The answer is yes. What we have to do is, first, you have to spray the object with a layer of powdered graphite. So you know that graphite is conducting electricity. So therefore, if you put some powdered graphite on top of it, or you can put metals, powdered metals on top of it, then that one is just like a objects coated with electrical conductor. So actually, it can also conduct electricity like a normal electrode. So after doing this one, okay, what you need to do is just electroplated as usual afterwards. So therefore, non-metal can also be electroplated. So what kind of example do we have? We can also plate something like plastic, or you can also plate something like glass. Okay, so these kind of things is also possible. Just want to draw your attention to the examples 32.4. This one is related to our last videos, which is related to the rate of electrolysis. So if you remember, I'll just very quickly have a look at the question. So the first one, okay, show electroplating of the iron ring with nickel. So you see that this time we are talking about nickel. So the cathode one, this is anode. Sorry. So this one is anode. This one is cathode. So you see that the metal, okay, the going to be plate, okay, will be put at the cathode part, okay, while the anode part, okay, these electrodes, as I'm talking about nickel, so I will put nickel right there. Okay, and then the solution, because we want to put nickel on top of it, so therefore I will have nickel sulfate, better not, nickel nitrate solution. Why not nickel sulfate? Because you may not sure whether nickel sulfate is soluble in water or not, because you know that sulfate sometimes it will form insoluble precipitations. So therefore this one prefer not. Okay, you put nitrate, then it will be a must for these chemicals to dissolve to form a solution. So part A suggests a suitable materials, easy. Part B suggests a electrolyte, done already. So part C, okay, you talk about the anode and cathode, you do it on your own. I want to draw your attention to part D. The rate of electroplating can be increased. Rate of electroplating can be increased by increasing the current. Okay, so you see that we got a rheostat there. Okay, we got a rheostat. So if we lower the resistance, the current can then increase. But the current cannot be too high. Okay, you have to give a reason for that. Just now we have mentioned, if you want to plate the thing nice, you have to control the condition. One of the conditions you have to control is the current cannot be too high. If you make it too high, okay, it try to stick up on the objects, then maybe this metal maybe are plated on it loosely. So therefore the deposit may peel off easily. Okay, so if too high in current, okay, then the things will stick on it very, very fast. Maybe the quality is not good. So therefore, you have to control the condition for that. Then, how can we increase the electroplating? Okay, do it better. So two other methods. So I remember one of them, two of them were mentioned in the previous video, but I didn't mention very clearly. I just want to remind you one thing. Okay, so remember one of them is talking about the distance between the two electrodes. I said that the distance is important, but I didn't mention whether you have to put closer to each other or further apart from each other. So the answer is, okay, they have to put close to each other. If you put closer, then the ions can move a shorter distance, then the electroplating, electrolysis process can be faster. Okay, so do remember, if two objects, they separate apart, far apart, okay, then the electrolysis process will be very slow. If you put them closer to each other, then the electroplating process will be faster. Other than that, easy. You have a solutions with a higher concentration. You can also increase the electrolysis. But of course, you can also like increase the voltage of the battery, like getting more battery and so something like that. Okay, so that's all, okay, for this area. Okay, so we just have a very quick conclusion for the anode. Okay, for the anode, we're going to have like the plating metal. So it can be like copper, it can be like silver or the other things. Okay, so for the cathode will be the object to be plated. So normally it can be like the key or the other things. Okay, so the third one will be the electrolyte. So the electrolyte should be a solution contains the ion of the plating metal. So do remember, for these actions, okay, you need to sketch the diagram and make sure the key is immersed into the solution. And also remember, okay, if you want to have a good plating, you must have a conditions control. Too high current may not be a good thing. So that's all for the video. Bye bye.